Hi everyone, I'm gonna show you how to create a moving heat source for CalculiX. Okay, let's first start with a geometry. We will create a brick. That's enough. Okay, then we will define a size and mesh it. Okay, so to create a moving heat source, we will need a curve that we want to follow. So we will create some vertices here, passed by coordinate. Okay, let's create some vertices so that we can generate the spline that we want to follow. And one more. Okay, I think that's enough. Then let's make a spline with all IDs that are free. And we will delete the internal vertices here. Yes, exactly. Okay, then we want to mesh this curve because we need nodes. From the nodes there will be later shot trajectory, fire rays at the surface. So we need to mesh this curve here. Doesn't look that bad. Okay. Then we will create the block for the volume 1. Then we are already ready to create the material. So yeah, we are doing heat transfer later, but let's just add this. Then we will need some density. And we will definitely need the specific heat. Yeah, why not the expansion? And if we want to run a heat transfer problem, we will also need the conductivity. And add the card to the material. Okay. So next thing is to create the section. We already defined our block. We'll assign the material ID 1 for this block. It's already assigned. Okay, now we can already create the moving heat source. So how can this be done? We just go into our create directory widget. We'll give this a name. Just directory 1. So we will need to select the curve, the start vertex, then the surface where this should work, the direction for the fire ray, not the Y directory, we want it in, yeah, Z directory, yeah, that's right, that's okay. Okay, then time begin, we will start when the step starts. Was work 10 to time 10. Then we can define array radius, magnitude for this radius. Let's say smaller radius, more magnitude. And already hit apply. Now the directory got created. We can control this with draw directory. Yeah, looks good. Okay. So next part is to create the initial conditions. For this we would like to choose the temperature. So we don't have a temperature defined that we can select or assign to the initial condition. So we will first create the initial temperature. Loads, boundary conditions, temperatures, yep, volume, that can work on all volumes. It's good, now we can assign. Oh, seems to be a bug with the highlight, okay. So, initial temperature is assigned. Next thing is we will need some field outputs, otherwise we won't have any colorful pictures. And we will the field output for the element. So let's make, what are we interested in? We want to see the nodal temperatures, frequency, it's all okay for me. So next thing would be the element. We want to have the heat flux shown. And now we're already at creating the step. We'll create the heat transfer step. Yeah, moving heat source. If we double click on this, we will adjust the maximum increment. Then we want to take control of the total time at start. Initial time increment. We are from 0 to 10. So the time period of step will be 10. Minimum increment. Maximum increment. Okay, and now we will only need to assign the trajectory, the field outputs. We'll need to create a job. . then we can already run it. It's finished, it's converted. Let's have a look. As you see, we got here the multi-block inspector. I just deselect the node set. Okay, how are the nodal temperatures? Yes. And how is the flux? As you can see, we can't really distinguish the different magnitudes, so the mesh is way too coarse for us. So we can either refine the whole volume, or we just copy paste here a bit from the examples. In Qubit you can switch between the Qubit command line and the Python command line. So what was done here, we can get access to the faces that will be drawn when we draw the directory through the Python API. When we got all faces, we can use the faces to more or less refine along the directory path. And that has been done here. So as you can see, we now have a way finer mesh than before. And when we draw this directory, you will now see that we got the higher resolution here. So when we rerun the job again, this will most likely take longer than before. As you can see, this results in 1632 heat fluxes that will be generated. But we are already finished. Results are converted. Oh, a lot more nodes here. So how does this look now? That's the nodal temperature. And as you can see, when you look at the flux, you can see there's 3 different magnitudes pretty clear. There we got 50, 30, and 10 that we assigned. Yes, that's the way to create moving heat fluxes for CalculiX. If you have any questions or need other features, just write me. Thanks for watching.